Welcome to our NLP class. This is part 12. In this class, we are going to learn about Naive Bayes Classifier, which is the modified version of the Naive Bayes Classifier. Do you remember the formula for the Naive Bayes Classifier? In our earlier class, we saw this as written as for number of words 1 to n for a given document, which is the ratio of two probabilities. One is the probability for the positive class, probability of positive given the word xi over probability for the negative class. This is basically the ratio of two probabilities. We were discussing about what is the problem with this formula. Here we are multiplying probability values ratios so many times, n times. In some cases, n would be very huge. When we deal with a very big document which has maybe 100,000 words, if you look at the vocabulary, maybe it might be 4,000 words or 5,000 words. Then we need to multiply 4,000 small values. It would be computationally cumbersome and then very difficult to interpret the value. The ranges of this value varies from 0 to infinity. When you compute this formula, the value ranges from 0 to infinity, and when the value is greater than 1, which indicates the given sentence is positive or it has the positive sentiment. If the probability score, final score f of x is greater than 1, then it is a positive sentiment. On the other hand, if the f of x is less than 1, then it represents the given sentence is a negative sentiment. Now we will see how we can modify this formula. The simple approach is just take the log of this ratios. Take log ratios, log of the entire value, which is pi of I equal to 1 to n, and ratio of two probabilities. One is probability for positive class and next one is probability for the negative class. How we can convert this formula? We know that how we can handle this log of multiplying two numbers. How do we calculate this one? This can be written as log of a multiplied by b is equal to log of a plus log of b. So when you move this log inside this one multiplier, then this multiplier becomes the summation. It becomes summation of 1 to n, and then same the probability ratio for the given xi and probability for the given xi for the negative class. This is our modified formula. This is log ratio. Here I think I forgot to include that log. Log value should go inside this one. This formula is called as log ratio. So in order to build this model, when you look at this model, it looks very simple, elegant. This is our mapping function f of x. Why do we need this mapping function? In order to predict our y prime. The y prime in our sentiment classes to see if the given sentence is a positive sentiment or it has the negative sentiment. What goes inside this mapping function? In order to compute this mapping function, what do you need? This log ratio. So we need to compute this log ratio for every word. For an example, if I have 4 words in my document or movie review, like movie, awesome. We consider these three words. For these three words, what should I calculate? First one is the log ratio for each word. Probability for positive given x1, where x1 is like, x2 is movie, x3 is awesome. And then calculate probability of negative for the given word x2. Similarly, I need to calculate the same log ratio for the second word movie. For the second word x2, and then same probability score for the negative class for the same word x2. And then finally, log of this ratio for positive class given x3 over probability of negative class for x3, and then we will get the final score. Final score is our probability value, this mapping function f of x. Here, what is the range of this f of x? F of x ranges from minus infinity to plus infinity, and the center point is 0. If the predicted value is greater than 0, if f of x, this mapping function is greater than 0, then the predicted final outcome is a positive sentiment. On the other hand, if this mapping function f of x is less than 0, then the outcome, final outcome, predicted outcome is saying that this is a negative sentiment. And this is how we can build a Bayesian classifier. Just look at this formula. This is very simple. Just we need to compute these simple probabilities. By just calculating the simple probabilities, looking at our vocabulary and then corpus, we can build a Bayesian classifier model. Now, I hope you all learned about this, how we can build the Bayesian classifier. We will see in our next class. Till then, thank you. Bye.